Hello. So in the lecture we didn't have time to look at strings. So in this video I want to shortly go through strings in Python. So a string is just a sequence of characters, right? So if we type in our string is equal to hello, how are you, right? And then we print our string, then we get this message. And if we have a look, type our string, then we see that our string is of type string. So a string is really just a sequence of characters, and in Python we can iterate over sequences, right? So we can do for character in our string print character. And we see we have this nice where every character is printed out. And we can even use the enumerate index character in enumerate our string. So we looked at the enumerate function in the lecture, right? So let me just print I, no, not I, index and character. So we see that a string is really just a sequence of characters. So we can do our string 12, for example, and we get the 12th character in our string. Now, an obvious question arises as to how can we represent characters in a computer? A computer contains numbers, right? Not text. So, therefore, let's write something about this. A computer contains numbers, not text, right? So how can we then represent characters in a computer? And the answer to this question is through a lookup table. So we have, and you can, so we have a correspondence between numbers and characters, and all computers in the world has the same table that says, okay, so for example, 32 is space, 33 is exclamation mark, right? So we know this. So all computers know this, that if what I have is a character, then if this number represents a character, then we have this one table to look at to figure out which character to display for this number. So let us view that in our for loop above. So, oops, never mind that. So if I write for index character in enumerate our string, and then I print, and I use these f strings that I showed you last lecture, the index character is presented by the number, and then we can type in code. I hinted towards that in the lecture, so we can do ORD to transform from a character to the corresponding number character. So if we print this, we see that the 0th character, age, is represented by the number 72. So here we have a nice overview of all the characters and which number is used to represent that character. So let me write a comment. We can use the ord function to go from a single character into the corresponding number or code point. So it's often, the characters are often called code points, or the numbers that represent a character is called a code point. And similarly, we can use the chr function to go from a code point to a character. So I said that all computers in the world has stored this lookup table that goes from code points to characters, or numbers to characters. And the system that we're using is called Unicode, and how it works is really quite genius. So in the description below you will see a link to a very good video by Tom Scott where he explains how the Unicode system works. What we're going to do now is sort of shift focus a tiny bit. So now we looked at Unicode strings, but another kind of strings that are very useful are byte strings. And a byte string can only be used to represent the first 256 code points, which is also known as the ASCII system. So let us create a byte string. Our byte string is equal to b a string. And then we can print our byte string. So you see this preceding b, that tells us that this is a byte string, not a normal Unicode string. So let us create a subheading here, byte strings. And we can type our byte string, and we see that it's of type bytes. Now, a byte string, the reason we want to use byte strings is that on a computer everything is represented as bytes, right? So a Unicode string, every element there can span several bytes. But on your hard disk or in memory, everything is stored as either 1, 2, 3, 4 bytes, not 1.5 byte. You can never go smaller than 1 byte, or so each location contains 1 byte of information, right? Or at least that's like a simplified image that you should have in your head. Now, because of this, it's very useful to be able to directly interact with byte strings, so you can directly interact with the file system. But that has its downsides, so let us try to create a string, byte string, a new byte string, and we have welcome to OS, right? If we try to create this, you see we can't create a byte string with the letter O, because it's not in, there is no ASCII code point that represents that character. So the O character takes more space than an A character, for example. And these kinds of strings were, we don't need them nearly as often as we need Unicode strings, but they were the default in Python 2, and is actually one of the really nice things with Python 3 is that you don't have to worry about Unicode anymore. It just happens automatically. And the next part that I skipped in the lecture was opening files. So when we open files, we automatically write them as Unicode files. So let us with open test file.txt in write mode as file dot write our string, or a new string is equal to welcome to OS, a new string, right? So now we've saved this file using Unicode, but we can also save this using another text encoding. So Unicode is the standard, but there are more. Before that standard was created, we had a lot of different of these lookup tables. So another one is Latin 1. So you can write test file Latin 1. And now we've created our two files. So let's have a look at their contents. Cat test file.txt. You see it works. Cat test file latin1.txt, and we get this question mark. And that's because this cat program that we run to read the content of the file doesn't know that the file is encoded in Latin 1 and not Unicode. So it finds this symbol and it thinks it's supposed to be represented in Unicode, but it doesn't know how to show that specific number, so you get a question mark instead. So this is not something you will encounter many times, but you might encounter it from time to time, that a file is either saved with a different encoding than Unicode. That can happen especially with really old files. And then it's useful to know that this is an issue, right? And we can open files, right? So just copy pasted that, and I open it in read mode, f.print f.read. So that works. However, if I try here with the Latin 1 file, then I get a Unicode decode error because it's not valid Unicode. This file is not valid Unicode because we saved it using Latin 1 instead. So then we have to do encoding is equal to Latin 1. And then it works. So here you see how when we interact with files, we might need to specify how a number is represented within a file. finally, I want to show you opening files in binary mode. So you can open a file in binary mode as well. So let's copy this. So we remove this encoding part, and instead we want to read it in binary. So we add RB. So this means open this file and read it and read the raw contents of this file. Don't convert it into letters. And then notice how we have this B here. So that B means that this is a byte string, and here we see, okay, so these are valid ASCII letters, and here we have a single byte, but it's not a valid ASCII letter, and then we have the final S. So you can still open these files and look at their raw byte contents, right? So that's called binary mode. We will not use binary mode in this module, but it's very useful to know that you can look at the raw contents of a file without changing it. So you can open absolutely any file on your computer system this way and have a look at the bytes inside that file. Now, that was it. You should really have a look at the lecture notes as well. And I'll see you next week.